Hello everyone. A very good morning to one and all present session 7G. Myself, Richa Shah, and this session will be moderated by me. On behalf of the Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 9th International Congress on Information and Communication Technology, ICICT 2024, London, UK. The 9th edition of the conference is being organized in a hybrid mode. The physical event was organized in London, UK on 19th and 20th February 2024, and the virtual event is being held through Zoom today and tomorrow, that is 21st and 22nd February 2024. I hope you will all enjoy the knowledgeable and interactive session throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes each for the presentations and 2 minutes for the question and answer. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I would like to introduce you all to our session chair. Dr. Farshid Tusi, he is a lecturer at Munster Technological University in Cork, Ireland. His research fields are feature locations, source code manipulation, data visualization, and machine learning. He also works with Java, Python, C, PHP, JavaScript, OpenGL, SQL, and Eclipse plugins. Our next session chair is Dr. Swati Nikam. Dr. Swati Nikam has total 20 years of teaching experience in computer engineering and working as an associate professor at Pimpri Chinchwad College of Engineering and Research, Pune, India. She has completed her PhD from SPPU Pune. Her research areas are cyber physical systems, information security, Internet of Things. She has published more than 30 plus research papers in reputed international journals and conferences. Currently, she is working as a departmental PhD coordinator, R&D coordinator, and for NIRF, NBA, NAC also. Welcome to the session, sir and ma'am. We may now proceed to the presentations. The next presentation I'd like to call Ms. Amal Azarul for the paper titled Application of Big Data Analytics and Artificial Intelligence in Medical Domain, a Survey. Ma'am, can you please start your presentation?
Good afternoon. My presentation is slide.
Yes, ma'am, it's visible.
Okay. Hello, everyone. I am Amal Azarwal, a PhD student from Ensam Mohammed V University, Morocco. Welcome to the short presentation on application of big data analysis and artificial intelligence in medical domain or survey. The present work aims to extensively explore the advantages, challenges, and application of employing big data and artificial intelligence in the medical domain. The outline of this presentation is as follows. First, I will start with the introduction and objective of the study. Then I will talk about some related works. After that, I will expand the big data analysis in medicine. Next, I will shed light on the use of intelligence artificial in disease diagnosis. Finally, I will end my presentation by talking about the conclusion of the study. Big data and intelligence and artificial intelligence in the medical field are versatile tools applicable in various sectors, such as commercial, academic, government, and public. They encompass diverse data types, including biological, biometric, and electronic health records. The integration of big data and artificial intelligence in the medical field offers innovative perspective promising a major transformation in healthcare delivery. This synergy between big data and artificial intelligence in the medical field offer innovative perspective promising a major transformation in healthcare delivery. This synergy between big data and artificial intelligence promises to optimize healthcare and improve the management of medical information and consequently make diagnosis more precise and treatment more efficacious. Some key examples of application of big data and AI in the medical field can be mentioned that like improved diagnosis, for example, to detect sign of disease, promising treatment, epidemic forecasting, like using big data technology for preventing epidemic like COVID-19, accelerated medical research, enhanced telemedicine, and drug discovery. This is some definition of big data and artificial intelligence. The integration of big data and AI in the medical field offers innovative perspective promising a major transformation in the healthcare delivery. In this survey, we initiated our exploration by reviewing recent works related to the topic. The influence of big data on medical research has been revolutionary, affecting network forces progress and transformation across various sectors of the field. For impact of big data on medical research, big data has facilitated a deeper comprehension of disease by empowering researchers to scrutinize extensive data sets and unveiling patterns and correlation that were previously unnoticed. In drug development, big data has expedited the process, enhancing the efficiency of clinical trials. It streamlines the identification of suitable candidates and enable real-time data monitoring, leading to quicker and more informed decisions. Indeed, recent studies have demonstrated that the implementation of big data analysis in healthcare environment has significantly improved patient outcome. They concentrate on demonstrating how big data principles are applied in healthcare. Advances in artificial intelligence facilitate the measurement and analysis of multimodal data, heralding an unprecedented era in extracting knowledge from complex data. Furthermore, it is crucial to ensure relevant and effective analysis of this data using AI techniques and algorithms. Tasks such as disease diagnosis, image segmentation, or outcome prediction are undergoing a revolutionary transformation owing to the recent advancement in artificial intelligence. The methods of AI, especially those of machine learning and deep learning, have made significant strides in recent years, revealing considerable potential to transform and automate medical practice. However, for fully effective and secure integration of these methods into the clinical workflow and multidisciplinary effort in implement. Medical big data analysis refer to the process of applying advanced analytics and computational techniques to vast and complex data sets in the medical field. It involves extracting valued information, patterns, and correlation from extensive collection of medical data, including patient records, diagnosis images, genomic data, treatment outcome, and more. Medical big data analysis aims to drive meaningful insights that can improve patient care in disease diagnosis, treatment planning, drug discovery, and contribute to advances in medical research. This analysis often involve the use of various methodologies such as machine learning, deep learning, natural language processing, and statistical techniques to obtain actionable information and improve health outcomes. Furthermore, the utilization of medical big data analysis has the capacity to improve predictive modeling capabilities within the healthcare sector. The analytical goals of medical big data encompass prediction modeling and inference, and the frequently employed technique in this domain include classification, clustering, and regression. The use of intelligence artificial in disease diagnosis is a rapidly growing field, offering revolutionary perspectives for medicine and healthcare. AI enhances diagnosis capabilities through advances in data processing and machine learning. Deep learning technologies have significantly evolved over the past decades, and many medical research projects have successfully used neural networks and classify, detect, and segment data. Machine learning are particularly valuable as managing big data in complex with deep learning and machine learning is effective in simplifying this complexity. Medicine faces a range of diagnosis challenges, especially in predicting incurable but treatable disease. This technological evolution has paved the way for earlier and more accurate diagnosis, which can significantly improve patient outcomes. Machine learning for disease diagnosis is a rapidly evolving field, revolutionizing how healthcare professionals approach the detection and treatment of illness. This technology enabled the analysis of extensive sets of medical data, providing new and more precise perspective for diagnosis. With the constant evolution of technology, machine learning methods are becoming increasingly crucial in disease prediction and diagnosis. Beyond its role as a data analysis tool, machine learning as an integral component of AI play a key role in enhancing healthcare system data to true found of this system, not only enable disease detection, but also safeguard human life through early and accurate diagnosis. When comparing machine learning and deep learning models, a major difference emerges in their application in AI, particularly in the medical field for diagnosis and treatment planning. Machine learning is a form of AI that enables software application to improve the accuracy of their prediction without recording specific programming for this purpose. Machine learning algorithms as historical data to anticipate new outputs. In contrast, deep learning as a subcategory of machine learning utilizes artificial neural network for learning from data. These networks, inspired by the human brain, can detect complex patterns in data. This table highlights the fundamental distinction between the two approaches in terms of their application in disease diagnosis.
Ma'am, just a gentle reminder that 10 minutes are over. You will have to
Okay.
wrap up.
Okay. In summary, this survey highlights the revolutionary impact of big data and intelligence artificial in the medical field, especially for disease diagnosis. We have demonstrated how these technologies can significantly enhance diagnosis and treatment, while emphasizing the ethical and practical challenges associated with their integration into healthcare. The ethical question surrounding in the use of artificial intelligence in the medical field cannot be ignored. It is imperative to ensure the confidentiality of patient data and balance artificial intelligence with human expertise to avoid dehumanizing care. Here are the reference used in the study. Thank you. Thank you for your attention.
Questions from the session chair?
Yeah, I have one question. Amal, thanks very much, first of all, for the presentation. So my question is about the ethical aspect of basically the use of big data analytics and artificial intelligence. So usually, as far as I know, usually when we are going to use basically medical data in artificial intelligence, we'll have to have basically a process of collecting data. So the data is usually sensitive when it is about basically when it is in the healthcare section. So was there any highlight when you were doing this survey, this paper basically? Have you seen any highlight about the ethical issues or the ethical concern during the data collection for this task, basically?
Yeah, thank you for your question. We provided a brief overview of the limitation of current area intelligence artificial technologies and potential area for improvements, covering various aspects such as ethical consideration.
Okay, so
Yeah.
you're following some sort of a standards when you're basically during the process of data collection. Is that correct?
Yeah. The survey discusses recent research works providing a current and the relevant perspective of the subjects and the ethical practice. It's provided in this survey.
That's perfect. Okay, thank you very much.
Thank you, sir.
Yeah, I have one question. First of all, thank you for the nice presentation. My question is like, what are the specific challenges when you are handling the medical domain data, and when you say it's a big data? So any specific challenge with respect to medical domain data?
Thank you, sir, for your question. The study can be practically applied by healthcare institution looking to add big data and technologies.
Yeah, so
We-
in that study itself, do you find any specific challenge, which is more prominent in terms of medical data?
Yeah.
Okay, fine.
Thank you. Thank you.
Thank you, ma'am, for your presentation. Now we can move on to the next presentation. Okay, there's a question from so you can ask your question.
Hi, how are you? Hi. Um, I have a question about the type of data that is used in the medical domain. My question is, what is the level of the use of audio data in the medical domain
Audio.
as applied on deep learning?
This form
Did you-
or type of data, it's
Yes, the type,
very used.
the
Thank
type of data. Yeah, the type of data, audio data. Is it
you.
very used? Is it largely used, or it is just limited?
It's very used more, but images data, it's more used for audio data. It's the most used images data. This is various models to use audio data, like invasive of diagnosis of cardio disease. We can use audio data and treatment with the deep learning.
Okay, thank you.
Thank you.
Any more questions? Okay, now we can move on to the next presentation. I don't think there are any more questions. Thank you, ma'am, for your presentation.
Thank you.
Now I'd like to call Mr. German A. Montoya for his presentation titled NIMFA Epidemiological Model for Analyzing. So you can please start your presentation.
Okay. Hi everyone. So well, I had problem with my audio previously, so well, it's okay. I hope you can listen to me, right?
Yes, sir, you're audible.
Okay. So I then will share my screen. Do you see that?
Yes, sir, it's visible.
Okay. Thank you. Well, give me a second, please. Okay. So the work I'm going to present is a work called an IFA epidemiological model for analyzing malware behavior in IoT networks. Are the authors, Martin Galvan, myself, Germán Montoya, and Carlos Lozano. This work are going to be presented by myself, by Germán Montoya. The main author is Martin. Unfortunately, Martin couldn't join us, but well, I will try to explain the work given by mainly by Martin and co-advised by us, by Germán, by myself, and Carlos. Okay, so this is the agenda. I will give you an introduction, the problem description, the proposed solution, the solution design, the implementation, the results, and conclusion. Okay. So, well, in the introduction, well, you know, we have we are going we are dealing, I mean, with a IoT network. This IoT network is compounded by several types of devices. The IoT devices, these are mostly sensors that capture some information from the environment, a physical or a chemical information, and then they have to transmit or to send that information to gateways and gateways for internet, and then from internet send this information to servers in order to that different persons can see these informations in their apps and can monitor and analyze the information captured by the IoT devices. Okay, so we have a lot of applications taking into account all the advantage that give us the IoT devices, like, for example, smart agriculture, medical application, healthcare, transportation and logistics, traffic monitoring, smart home, and many more applications. Okay, in the recent years, this technology has increased a lot. Okay, so for the year 2050, is expected more than 100 billion of devices. This is a great knowledge, but the problem is that this obviously can attract the miracle of the side of the malicious individuals, okay, because they could appear to attack our IoT network. Okay, how? By performing several kinds of attacks. For example, denial of service attacks, ransomware, okay, and exploit, for example, the denial of service in order to, for example, stop the IoT service and stopping the service. Obviously the service is inactive for all its users, so it's very a problematic situation. In the ransomware, obviously these guys can kidnap our information, and then we have to pay a very high amount of money to free our information. And in the other hand, we can have exploits that can, for example, performing a malfunction of the IoT devices, affecting negatively the development of the operation of the network, right? So in detail, for example, in the year 2016, we have the Mirai botnet. It was a real attack. This attack infiltrated 1.2 million of IoT devices. So it's a very high, a great amount of devices infected. This botnet performed a distributed denial of service attack, okay, to affect obviously the security of the cameras devices in a certain network. And obviously this Mirai, for example, this botnet infects IoT nodes one by one, like an infection, like an epidemic, right? So recently there has been some studies in which they have embarked on the development of epidemiological models to try to analyze or to represent the propagation or the infection of this kind of attacks. That is the malware. Okay, so our proposal consists to develop a CIS epidemiological model, right? And our model is implemented using the NINFA model that we're going to explain later. And the idea is to compare these results against a Markov chains model. Okay, NINFA model is this is what it means. Later we are going to give more details about this technique. Okay, so because we are going to propose a CIS epidemiological model, we are going to say the basics of this solution. Okay, so this is the representation of the CIS model, this figure, and then in this box marked with an S, this corresponds to the healthy individuals or healthy nodes that are in the network, but are vulnerable to catch a disease. In this case, to catch the malware. Okay, so these nodes are also known as susceptible individuals. Okay, and then in this other box we have the infected individuals. Okay, so these infected individuals are simply susceptible individuals that has catch the pathogen or the malware. Okay, so individuals, this kind of individuals, the infected individuals, are capable of transmitting the disease or the malware. Okay, this beta parameter is the infection rate, and the alpha is the recovery rate in this model. Okay. Sorry. So once we have clear these concepts, then we pass to design a Markov model. Okay, did you know the Markov model is useful, is very useful to represent discrete states and the probabilities to go from one state to other state. For example, to go from a susceptible state to infected state. So at a given time, right? And then when we can represent the Markov model applied to our CIS model, we can represent it through this equation, this large equation. So, okay, so U is the generation matrix for the Markov chain. A is the adjacency matrix, which have the probabilities to go from one state to another state in relation from each node Y with each node J, for example, and XP, for example, it describes if a node is infected, one, or not, that is susceptible. That means that its value is 0. Okay, but there is a problem with this solution, that this problem it represents high cost in terms of time and space. Okay, so with this approximation, with a Markov model, we can perform this model, but with not a large number of nodes in the network, more or less 50, maximum 20, and more nodes are very costly. But okay, so in this sense, then we propose to use an infra model that is another strategy to overcome the problems in terms of space and time given by the Markov model. Okay, so basically the infection probability that we saw in the Markov model, that is this equation. This equation in the NINFA model transforms to this equation here, and this equation says that the chances of getting infected depend on infection rate and the number of neighbors, or the surrounding number of nodes that has a certain node Y. Okay, so the idea is transform this equation to this equation through using the NINFA model approach. But the model is not finished yet. We have to apply an internal method of the NINFA model that is called mean field approximation, and then the infection probability, the QI, is transformed by the average by the average probability of infection. That is E sub yi. Okay, so all this expression. And then, well, once we have this expression is traduced with
Sorry to interrupt,
with a
sir.
Markov model. Sorry?
Sorry to interrupt, just a gentle reminder that 10 minutes are over, so you'll have to wrap up.
Okay. I will go fast. Okay. I'm sorry. Okay, so this is the equation of the NINFA model. And then, well, this Markov model is will transform in a Markov differential equation. Okay, to represent the continuous behavior of the infection. Okay, so this is the solution architecture. We have these blocks, and these blocks basically are useful to, well, to final updating the adjacency matrix. That is the probabilities from going to one state to another state, and then to obtain a graph with the infected nodes. Okay, so in the results, well, we have the idea is to compare our NINFA model with the Markov model, for example, and we performed some tests, for example, and these tests, the parameters was the delta was equal to 2. This is the recovery rate. The infection rate was 1.8, and basically the critical node for NINFA and Markov were basically the same. So in this sense, the NINFA and Markov were equal. For example, the critical node for this network, the NINFA, using the NINFA model, was the node 2. And in this network, the critical node was the node 3 for the Markov model. And we can see that is basically the same node. Okay, so the critical node, okay, what is the critical node? The critical node is the node where if the infection starts, the time expected until it ends will be longer. Okay, so in comparison with the Markov model, again, the NINFA, for the NINFA simulation, darker color means more nodes infected, and for the Markov simulator, blue means fewer nodes infected, and yellow means more nodes infected. Okay, for the NINFA critical node are several. In this graph, we can observe that the critical nodes are several. For example, the nodes 0, the 1, the 4, the 5, the 7. And if this was considering that the entire infection state is reached into time here, faster than in Markov simulation. Well, we did also another comparison that was against the Gillespie simulation. The Gillespie simulation is basically is a software that can emulate an infection, and then we did this comparison in order to know if how reliable was the NINFA model. Okay, so we compared the NINFA model against the Gillespie simulation, and we obtained for the Markov model, we obtained a p-value of this value, and for the NINFA was this value. This very low value means that our NINFA was very reliable in terms of to represent an infection. Okay. So, and well, the last result is that the network is in terms of the network size and the time complexity test. That this is the comparison. Okay. Oh, sorry for this percentage. This is a mistake. So we did test in terms of out of memory, and then test in terms of the network size of temporary unfeasibility, and we obtained that the NINFA obviously perform a very advantageous results. Okay, so in conclusion, the NINFA model can handle more nodes with a tremendous difference in magnitude for both cases, for memory and for temporary untraceability. And then, well, obviously, it's better than the Markov model to simulate this kind of infections. And then, obviously, we did some more tests. For example, changing the size of the networks and test the time of execution of the NINFA model, and we obtain this curve behavior. Concluding that the NINFA model has a time complexity of n squared 2. Okay, so the conclusions are, well, it was possible to design an epidemiological model for IoT networks with a significant improvement in time and space complexity. We compare our algorithm with the Gillespie simulation, and we obtain a reliable behavior of our NIFA model. And then, well, finally, with this, we can be sure that our model is reliable for studying different topologies and helping network designers and managers to test different topologies and determining how secure is the network. Thank you.
Thank you, sir. Any questions from the session chair?
Yeah, I have two small questions. So first of all, thanks very much for the presentation, German. My first question is about your choice of model for comparison, Markov model. So I'm not really familiar with the field of IoT myself, but in terms of comparison, I was wondering if there is any other alternative model that you could compare your proposal, basically your proposed solution to it, or is there any AI-based model that you could also compare your solution to it?
Well, in the literature, we didn't find another technique different from Markov model. So for that reason, we compare against it. But for example, it's possible to check a comparisons with using different epidemiological model. For example, not using a CIS model, but using, for example, a SARS model. So a SARS model is a model where you don't only have a susceptible and infected node, but you have a susceptible and infected and exposed and recovery node. So you can do more complex scenarios in terms of the epidemiological models, and in terms of the Markov model. It's possible to do simulations, discrete event simulations, but and using maybe another probability approach. Maybe it's possible, but we couldn't find other kind of solution apart of Markov models.
Okay, that's fair enough. So my other question is about, so in one of your later slides, you showed the p-value that you got, and you were comparing that the p-value that comes from your solution is a lot smaller than the other p-value. So my question is that, was p-value the only metric you could basically use for comparison, or because, as I said, that I'm not fully familiar with the field, so I was just wondering, was there any other metric apart from p-value to compare your model against Markov model, or p-value is the only one that you could compare it?
Well, the p-value was a metric to obviously to compare how similar was the infection in a network simulated by the Gillespie algorithm. how was the behavior of the infection of the network, and the p-value. Well, this metric was selected by Martin. I mean, because it's a very reliable. It was the most reliable metric that
Yes.
he found to obtain a certain a measure of to achieve a certain comparison between how the infection spreads, how was the spreading of the infection in the NIMFA model in comparison with the Gillespie. We didn't find another metric
metrics, yeah.
more
Okay.
more reliable. Yeah.
Yeah. Okay. No, thanks very much for that. That's from me.
Yeah. I have one question. Thank you for the presentation. My question is like, did you find any exceptional condition? You have presented this comparative, with the other model, Markov model and all. So did you find any exceptional condition where this model, NIMFM model, will not work as per your expectation? Maybe in terms of network size or time or any other aspects. Did you find any exceptional condition where this won't work?
A part of space and time. Well, maybe I don't know if it's a special condition, but it's necessary to maybe to clarify that. Well, the Markov model is a discrete approximation. Okay, it's a technique that operates in a discrete representation to represent a certain phenomena, in this case an infection, and the NIMFA is a technique that is useful to represent a continuous phenomena. Okay, so the Markov is a discrete. It is useful to represent discrete a phenomena because the Markov chains according to its to his concepts. You have different discrete states, okay, and you can go from any discrete state to any other with a certain probability. But in the NIMFA model, the scenario changed a little bit because, well, you don't have exactly discrete state, but you have more continuous a continuous behavior to represent. So it's necessary to take into account that to achieve a difference between these two methods. So I don't know. It's a difference that is necessary to take into account in order to analyze the results of the infection spread.
Okay, thank you.
Okay, so now we can move on to the next presentation. So I'd like to call Mr. Manduko. Sir, his paper is titled Deep Learning Based Diagnosis of Leukemia in Africa, Case of Acute Lymphoblastic and Acute Myeloid Leukemia in Single. So please could you start your presentation?
Hello, everybody. Hello, everybody. Are you see our presentation?
Yes, sir, it's visible.
Okay. Let me just few minutes to finish. is okay?
Yes, sir.
Ladies and gentlemen, thank you very much for coming along here today. My name is Dr. Mandi Kuba. I am Associate Professor at Polytechnical High School Computer Engineering Department. I'm here with Therese Diagne, my master's students. Therese is a graduate in a master in artificial intelligence and big data. In our presentation, we will talking you about our paper entitled Deep Learning Based Diagnostic of Leukemia in Africa, Case of Acute Lymphoblastic and Acute Myelolytic Leukemia in Senegal. Here the outline of our presentation. Firstly, we are going to talk about our background and motivation to properly present our research area. Secondly, we will going to present leukemia. The next section present our methodology. The result followed by a discussion will be the subject of the next section. We will finish off by taking a conclusion and some future works. I'm now handing over to Therese.
Okay, thank you very much. We will start with the background and motivation. So, cancer remains the leading cause of death from disease among children, with more than 300,000 children diagnosed with cancer each year. Among pediatric cancers, leukemia represents a third of cases. It is essential to note that among the different types of leukemia, acute lymphoblastic leukemia constitutes approximately 3/4 of cases in children, followed closely by acute myeloid leukemia. Early and accurate diagnosis of leukemia is of crucial importance for effective treatment. However, morphological analysis has significant limitation, particularly in distinguishing different types of leukemia. Additionally, current methods such as immunophenotyping require expensive equipment and specialized laboratory skills. This complexity highlights the urgent need for new, more accessible and effective diagnostic approaches. In this context, our study aims to explore the potential of machine learning techniques to aid in the process of early and accurate diagnosis of leukemia in children, thus provide new perspective in the fight against this devastating disease. So, the research of our problem. Let's move on the research problem. We are asking the following questions. How can artificial intelligence and computer vision improve the diagnosis of acute lymphoblastic leukemia and acute myeloid leukemia in Senegal? Which AI models are best suited to address this challenge, given limited data and computing resources? And how to overcome the obstacles linked to lack of data and resource constraints to optimize the potential of AI in the diagnosis of leukemia in Senegal. This question defines the core of our research problem and will guide of our effort to find innovative solutions. So, leukemia, we're going to talk about leukemia, understanding types and diagnosis. So leukemia is a type of blood cancer that results from the uncontrolled proliferation of immature blood cells in the bone marrow. We have different types of leukemia classified according to depending on the type of blood stem cell from which they come, depending on how quickly the disease develops. So we have acute lymphoblastic leukemia, acute myeloid leukemia, chronic lymphoblastic leukemia, and chronic myeloid leukemia. This is some example of ALL, AML, and CLL and CML. So, diagnosis of leukemia follows several steps, such as patient history, blood tests, bone marrow testing, and molecular tests. We will now move on the presentation of our research methodology. First, we carried out a comparative analysis between the yellow V8 and VIT models. This phase involved with collecting data, pre-processing it, followed by applying that data to the two separate models, yellow V8 and VIT. Then we carried out a comparative evaluation of the result obtained. This approach will allow us to select the model best suited to our Senegalese context. Secondly, we undertook the collection, labeling, and validation of data specific to the Senegalese context. After pre-processing this data, we submitted it to the model chosen following the comparative study. Finally, we analyzed the result obtained in order to better understand the effectiveness of the model in our particular context. Now, let's move into the detail of our analysis by first looking at the VIT model, followed by an exploration of the yellow V8 model. So, what is a vision transformer? The vision transformer is a neural network architecture that applies the transformer model, originally designed for natural language processing to the domain of computer vision. Rather than using convolution, it divides an image into patches, treat them as sequence, and then put two blocks of attention-based encoder. So what is a Yellow Viet? Yellow Viet is a computer vision model developed by Ultralytics that support training model for object detection, classification, and segmentation. The architecture of Yellow Viet is mainly composed of two distinct parts, the backbone and the head. The Yellow Viet backbone includes two main parts, CSP.NET 53 and EfficientNet. The Yellow V8 head is responsible for predicting the bounding box and class probabilities of objects in the input image. It is made up of a series of convolutional layers and fully connected layers that process the output of the backbone and generate the final prediction. So we're gonna present the comparative study dataset. The dataset we use for the comparative study is the CNMC dataset. The CNMC dataset contains image of blood cells from patients with acute lymphoblastic leukemia, as well as of normal blood cells. Here are some examples of these images. So this is how the data distribution looks like. In order to strengthen the representation of the underrepresented normal class, data augmentation was carried out, thus doubling the number of normal samples in the training and validation set. In our first attempt at training with VIT B16, a version of VIT pre-trained with an input patch size of 16 by 16 pixels, we encountered the source limitation. To overcome this, we reduced the size of our initial training set by retaining only 60% of the data, or 5,080 samples. Since we were working in a Google Colab environment with limited resources, these constraints led us to select a more manageable subset of data while maintaining a balance between places to ensure the quality and
Excuse me, ma'am.
feasibility of our project.
Just a gentle reminder that 10 minutes are over. You'll just have to wrap it up a bit quickly.
Okay. This is how the data distribution looks after our first experience. So we're gonna show the result of the comparative study. This table shows the performance of both VIT and Yellow V8 model architecture. Both models were evaluated using K-quality metrics, including precision, recall, and F1 score. We see that in terms of precision, recall, and F1 score, VIT has better performances. We also see that the VIT model, although revolutionary in the field of computer vision, compared to the Yellow V8 model, requires more resources. Let's now move on to the data collection, labeling, and validation part in the Senegalese context. These different steps were following. These different steps
yeah, this one step was following were following for, and here are some example of images from our dataset. Okay. For the pre-treatment, we have the distribution of our data before and after data augmentation. Results and discussion. To set up the model, we did transfer learning using pre-trained model, YOLO V8. The result of ALL and AML cells detection are shown in this table. We have on average very good metrics with MAP 50 of 98%. The confidence matrix illustrated is an essential tool for evaluating the performance of our leukemia cell detection and classification model for ALL and AML. However, it is crucial to consider the specific context of our dataset, where each input image contains an average of 7 instances of either ALL or AML cells, but never both simultaneously. Image A shows the validation set images with their label, and image B shows the validation set images alone with their prediction. The results obtained by our leukemia cell detection and classification model are promising, demonstrating its ability to accurately distinguish the classes of acute lymphoblastic leukemia and acute myeloid leukemia. Okay. For our contribution, the creation of a dataset specific to Senegal for the detection of acute lymphoblastic and acute myeloid cells, rigorous comparative approach to find the appropriate model for our context, development of a detection model for acute lymphoblastic and acute myeloid cells. Also demonstrating the effectiveness of transfer learning for small dataset. For the perspective is efforts in data collection from medical institutions and health centers across the country, integrate additional clinical data like age, sex, medical history, and implement MLOps best practice for model management and data governance. This ends our presentation. Thank you for your attention.
Thank you, ma'am. Session chair or anyone, any questions?
No question from my side. Thank you.
Okay, ma'am.
Yeah, I just have a small question about the process of data collection. So I saw that you were mentioning about the use of YOLO as basically as the model. So have you used any extra data to further training the model, or you use the model as it was basically? So could you just explain a little bit about the process of data collection and what kind of data you have used?
Yes, we use the CNMC dataset for comparing the both model, VIT and YOLO V8. The CNMC dataset is make classification between LLA cells and normal cells. For after comparing this model, we see YOLO V8 is better. After we choose YOLO V8 for our own context, the Senegalese context.
Okay, so the data is basically localized, so it is specific to the country of Senegal. Is that correct?
Yes, is that we use Infinal for YOLO V8, with our own data set we collected in Hospital Center Dalal Jam, the Dalal
Okay.
Jam National Hospital Center.
Okay. Thank you very much. Thanks.
Thank you. Thank you for presenting. Now we
Okay.
can move on to the next presentation.
Thank you very much.
Thank you very much.
Now I'd like to call upon Mr. Dhruv Gupta for the paper titled Defense Lit, an effective lightweight GAN-based image defensing model. Sir, you may please start your presentation.
Everyone, so I'm Dhruv Gupta. I'm currently pursuing my MTech in Computer Science and Engineering from Indian Institute of Technology, Banaras Hindu University, Varanasi, India. So today I am going to talk about two very interesting topics. The first one is image defensing, and the second one is knowledge distillation. And then a combination of them, which was actually used to train my model. And so basically, I have built an effective lightweight GAN-based image defensing model, to whom I have named defense type. So let me start with what is image defensing. So basically, image defensing refers to the process of removing fence structures from an image to create an image that is basically structurally similar to the original image with no fences. So in this work, we basically have attempted to improve upon an existing GAN-based approaches. Here, GAN is being referred to as generative adversarial networks to image defensing by developing a lightweight GAN model that can produce results that are similar to the state-of-the-art methods, but is very less in the number of parameters processing so that it can be integrated with the low processing devices. So basically, in the literature review, the field of GANs and the field of image defensing has seen vast advancement over the couple of years. We started with conventional image defensing methods where the chances of error were very high. Basically, we have to identify fence regions based on their texture or patterns, and then we will employ various attention models to predict the regions that are very likely to have fences. But if there are cases with overlapping or their colors weren't that much clearly separable, then those can produce very high errors. And they require a very large or huge amount of data set also to train those kind of models. Then came the GAN-based approaches. So in GAN-based approaches, there were basically two kind of approaches. The first one is the two-step approach, where we'll employ a GAN to detect the fence. And then after removing the fence, we'll employ a second GAN to impinge the image so that it is structurally similar to the original image. And then came one-based approach where we will employ a single GAN to do both the tasks, where to remove the fence by detecting the fence and also create visually a comparable image. So the motivation for our research work was, as I have already discussed, the above literature reveals that all the models that currently can do the task have very high number of parameters, and they cannot be run on low processing power or low edge devices like smartphones or mobiles. So with the advancement of smartphones, there has been a particular need, so that we can say this was our first attempt to build a model that we can think can run on these low memory devices. And using those models was very much pricey, or we can say expensive. So to train such models, there was a technique that we explored, which is known as knowledge distillation. So now I will discuss what is knowledge distillation. So it is basically a model independent process. It can be used anywhere where knowledge is transferred from a computationally expensive large model, which we can refer to as a teacher model, to a simpler and a more smaller but effective neural network model, which we can say as a student model. So there can be usually three categories of knowledge. The first one is the response-based, the second one is feature-based, and the third one is the relationship-based. In the response-based knowledge, what we can do is that we will take the final output, or we will take the features that come from the final layer of a neural network, and we'll try to compare, or we'll try to make the student model learn the features of the final layer produced by the teacher model. Whereas in feature-based knowledge distillation, we can do this task at any layer and on multiple layers as well. While in relationship based, we'll, instead of trying to learn the outcomes of a particular hidden layer or the final layer, we'll try to learn the weights and biases which will represent the relationship between individual layers of a neural network. So in this, so the contributions of our work is basically, we have trained a deep learning based knowledge distilled student network, where we have used response based knowledge distillation, that is the outcomes of the final layer of a teacher model, to employ for defensing of images, and which can outperform, or we can say which can give comparative results in terms of response time, number of parameters, and the efficiency of the model. And we don't want to compromise on the accuracy to a very great extent. So according to our knowledge, this is the first attempt at developing such a smaller model in the field of image defensing. And this is our first attempt to in the field where we can think of something, some model which can be integrated with low edge cutting devices such as smartphones or resource content devices. So the approach is basically, we'll take a fenced input images or a data set of fenced input image. So a GAN basically consists of a generator and a discriminator, where the generator will produce an image and the discriminator is basically a classifier. Will try to separate the real image from the produced image, or we can say as the fake image or the generated image from the generator. So we'll take the input fenced input image and we'll give it to the generator, and it will produce a corresponding defense output image. So that defense output image will be given to the discriminator, which will try to separate the real image, that is the ground truth image, from the generated image of the generator. Then we'll apply the loss functions, which I'll discuss later. Basically, we have used 4 types of losses. And then in this way, we will train the weights and biases of the whole GAN model. So basically, let me explain the architecture. So in GAN, there is a generator and a discriminator, both of which are individual neural network models. So in the generator, we have followed the unit architecture. Basically, by unit architecture, I mean is that it is basically a combination of encoder and decoder, where the encoder will reduce the dimensional of the input images to a very low dimension, thus learning the representation of the features of that image. While by decoding, we will make the smaller dimension again to the original dimension of the input image, which is basically 256 cross 256. And while decoding, we are trying to learn the relationship between different features, or the location, spatial relationship between the features of the image. So in the unit architecture, there are some skip connections also, because while encoding the image and while decoding the image, there is a high chance that some of the information might get lost. So we don't want much information to get lost over the area. So that is why we have used skip connection also. So now the discriminator. Discriminator is basically a general classifier. Here we have used 30 cross 30 patch GAN architecture. That is to improve our efficiency, because in general classifiers, what we do is that we will input the generated image and the real image also, and it will give us the probability that with how much probability the model can say the generated image is similar to the real image. But here, instead of getting a single number or a single probability between 0 to 1, we'll get a network of 6 cross 6 cross 1. Basically, it is a matrix of 6 cross 6, where each cell, 1 cross 1 cell, will represent the probability that a 14 cross 14 portion of the input image, or the probability that a 14 cross 14 patch of input image is similar, of the generated image is similar to the actual real image. So in this way, there is a fight between the generator and the discriminator. And to win this fight, each model will get trained against the other. Basically, the generator will fight with the discriminator, so that uh, it can really predict the generated image from the real image, while the discriminator will fight with the generator so as to produce generated images which are really very similar to the real image. So now the loss functions. Basically, we started with only 2 losses, that is adversarial loss and the mean absolute error loss. So the adversarial loss is basically a simple binary cross entropy loss between the teacher generated output and the student generated output, to check how similar is the student output with that of a teacher output. While the mean absolute error loss was used so that the generated image should be structurally similar to the real image also, because we don't want just the student output to be similar to the teacher output. It should be similar to the original ground truth level also. So we have used L2 loss also and L1 loss also, but L1 loss gave better results than the L2 loss. Now, after much research, we came across two more loss functions, that is the perpetual loss and the mask loss. So first I'll discuss the mask loss. Mask loss is basically, since we had fenced images, so using the mask loss, we can create separate images which has only the fence part or the mask part, and we'll compare that with the teacher model's mask image also, so as to get a better identification of the fences. And perpetual loss is basically training our outputs with some of the standardized models that are used across the world. Like here we have used the VGG19 pre-trained models. And since VGG19 has been trained with a huge data set of ImageNet and has been accepted worldwide, this is basically classified also. So we'll take the feature representations of the VGC19 network also and the feature vector of our student generator also, and we'll compare them so as to train the generator to give better results. Now our dataset consists of basically 8384 pairs of fenced and defenced pairs of images, which each with 256 cross 256 dimensions. Out of this, we took 200 images as a part of our validation dataset, and rest were used for the training purposes. In addition to this, we have a dataset of 413 images to test our model. And basically, this dataset comprises of different type of images representing a diverse dataset. So our model could be as generalized as possible. Here we have used, as you can see in the images also, there is a regular, there are some kind of images with regular fences, some with irregular, and some with flipped dataset. For creating the flipped dataset, we have basically used the data augmentation techniques. So as you can see in the results, while comparing the number of parameters, so basically the teacher model contained 54
So
54
just a gentle reminder that 10 minutes are over. You'll
Yeah,
have
sure.
to wrap up. Yeah.
Okay, yeah, sure. So basically the student model as you can see, has 20% of the teacher's parameters, and still it is able to perform in comparison with the teacher model. And you can see the response type per image, that is also reduced to a great extent. And MOS basically stands for mean opinion score, that we have used within our institute. We have basically given the outputs of teacher, student, and the ground truth to a bunch of people, and told them to rate individually from 1 to 5, 5 being the greatest or the very good output. So in that way we have calculated, and you can see the mean absolute error also. The student error is greater than the teacher, but to a very slight extent, and which was again our motive. So these are the qualitative results. As you can see, the input image, the teacher and the student images outputs are very much comparable to the teacher outputs. And these are for the flipped dataset. And these are the qualitative comparison with the other state-of-the-art models. Now we come to the conclusion part. So basically in this study, we have developed a knowledge digital student model with a teacher model, so that it can be used with low edge processing devices, has a very less number of parameters, and in terms of efficiency is very good than the teacher model, which is evident from the qualitative and quantitative results. And the future work basically involves two parts. Since we have used image defencing, we can extend our work to video defencing also, but we need the appropriate data set for video defencing. And there are a couple of other things that we need to work upon. And other than video defencing, we can also improve our model on irregular data set. As you can see in the images, like in the irregular data set, there can be various type of fences. There can be spaces in the fences, there cannot be. So we need a good data set and a vast data set to improve our model on irregular images. So, thank you.
Thank you, Dhruv, for the presentation. I have one question.
Yes,
Like you mentioned it as a, for a lightweight model. Okay.
Yes, ma'am.
So what is the footprint?
I'm sorry, ma'am, I'm not clear upon your question. Could you please
You
elaborate
said
it a
it's a
little?
lightweight, defense light is a lightweight model, in the
Yes.
constrained environment, it will work.
No, actually, by lightweight, I meant is that the number of parameters and the other things that are like the processing power and the number of parameters will be required very less in case of our student model.
Okay. In that sense, you mean it is lightweight.
In that sense, I meant it was like.
Okay. Okay. Yeah. Thank you.
Thank you.
Yeah, that's all from my side.
Any more questions from this session, Chef?
No question from me. Thank you.
Okay, we can move on to the next presentation. Okay, moving on to the next presentation. Mr. Gunther Dreven, he'll be presenting his paper titled Digital Wellness of Preschool Children, the Story of CyberCat and the Consequences of Hacking. So please could you start your presentation? Sir, are you available right now?
Hello, I am Given Mnisi, and I will be presenting a paper titled Digital Wellness of Preschool Children, the Story of CyberCat and the Consequences of Hacking. The outline of this paper will be as follows. The COVID-19 has led to a widespread school closures, including preschools. This has in turn forced many people to communicate and learn through mobile devices. Young children in particular are vulnerable to the unforeseen risks that come with using digital devices. A UNICEF survey confirms that 70% of children utilize the internet without their parents' permission. Preschool children in particular are susceptible to the internet's risk because they are accustomed to it from using it at an early age, but typically lack the skills to realize or risk and do not understand how to defend themselves. So the aim of this paper is to develop a serious game that will spread cybersecurity awareness among children. Its intent is that it can be played under the supervision of a parent or caregiver. The phrase being well in a digital society is used to encapsulate the concept of digital wellness. It means that users should be knowledgeable when it comes to navigating cyberspace and understanding the potential threats and opportunities that are associated with cyberspace. Digital wellness includes three key elements, namely physiological aspect, which concerns the physical condition that can result from using digital media, behavioral aspect, which revolves around the user's behavior and the activities they engage in. Finally, psychological aspect, which consists of cognitive functioning, emotional balance, and mental health. To effectively promote cybersecurity awareness, there are several preferences in which children learn best, which can be observing the environment, listening to various sounds, exploring their surroundings, asking curiosity-driven questions, engaging in activities, and constructing or building structures. A serious game is a game in which education is the primary goal rather than entertainment. Johan Alles classified games into three types, which are entertainment games, which are focused on entertaining the user, serious games, which combine the funness and the seriousness, and gamification, which is adding game aspects to non-game environments, such as the progress bars, then quizzes with immediate feedback. The book titled Digital Wellness, Let Us Play in Safe Nest was written by Fisher and von Solms in 2016, which is freely accessible to download. This book has been specifically designed to cultivate a culture of cybersecurity among children. It features animal characters that are familiar to African children like hippo, cat, rabbit, bird, or snail. The stories of animals are relating to cybersecurity with short morals at the end. So the digital wellness game is based on the digital wellness book and is supposed to meet the following criteria: to be fun, age appropriate, and to raise awareness of digital well-being. It consists of 4 scenes that are aimed at spreading cybersecurity awareness that will be discussed in the upcoming slides. The first scene is the main menu scene, which serves as a selection screen for choosing a game. The second scene is the poem scene that it consists of the chosen story, which will be presented to the screen and read to the child. So this poem is about a cat that started writing a few code of lines, eventually got better and started stealing money and sending it to its friends and family, eventually got caught and went to jail. So the moral of the story is that hacking is an example of online legal activities and there are consequences for illegal actions. The third scene is the quiz scene, which consists of 4 random questions that the main idea of the quiz is to test whether the child has gained some knowledge from the poem, and the quiz results display how many answers the child got right. Finally is the minigame scene. So this minigame is more like a reward for the child for making it far. In this case, it is about distinguishing the legal and illegal activities that may be found in the digital space. This game was developed to address the dangers of hacking in a playful way. After the development of the game, it was sent to 21 experts in the field of gaming and preschool education. The first question that was asked is, how do you think the game is in promoting cybersecurity awareness among children? And it received a 4.6 average. Then the second question is, do you think preschool children will enjoy playing the game? 15 of the reviewers responded with a score of 5, resulting in an average score of 4.7. 2 questions were asked to determine which aspects of the game can capture the attention of preschool children the most, as well as aspect of the game that needs to be improved upon. Finally, there was an open-ended question to the reviewers whereby they shared their feedback, suggestions regarding the game. One of them was, this game is perfect for kids. It is very educational and it is aesthetically pleasing for kids. I love it. So the key contribution of this paper was to incorporate an additional poem into the existing digital wellness game. Future work includes the evaluation of the game by observing preschool children while they play the game under the supervision of a caregiver. Additionally, expertise from various fields, including psychology, game design, and technology usability will also be enlisted to thoroughly evaluate the game's effectiveness. Finally, frameworks such as those proposed by Bucci to model the interplay in the form of both harm and benefit of video games on digital well-being of preschool should be investigated. Thank you for your time. Any questions? While you guys are asking questions, I can play a short clip of the game.
ICICT. ICICT. There was a cat, a cyber cat, who wore a very tall black and white hat. He was very good and got much better to enter restricted sites. To gain entrance to these, from good to better, hard became easy and CyberCat went in everywhere. The moral of the story is, hacking is an example of illegal online activities. Here are questions you can discuss with your parents. When you suspect someone you know is doing the same, what can you do about it? Is this online activity legal? Cyberbullying. Calling your friends. Phishing. Watching cartoons. Very good. Cyber collect. Slide the cat to collect coins. However, beware of the bullies. Collect 20 coins to win. If the bully hits the cat 3 times, you lose. Try again.
Thank you. Any questions?
Thank you for a wonderful presentation and video. My question is, what I'm trying to understand is this one game you have prepared, right?
Yes.
So, I mean, are you targeting some other topics also or you are
Yes.
trying to expand this itself? I mean, because under
So
the cyber umbrella, there are so many, vulnerable topics which they need to understand in a simpler way.
Yeah. Okay, so originally the book consists of 14 poems. So currently there are 4 games that have been implemented into games. So the other games, they target topics like cyberbullying. The other one talks about password, how to keep your password, like make your password long. Then the other one talks about the other books talks about the screen time. Yes, so there are lots of cyber security topics that are covered, but some of them have not been implemented into a game.
Okay. Yeah, thank you.
So I have also a question. First of all, thanks very much for the presentation. Very interesting work. During your presentation, I noticed that it seemed that you had run a survey asking those questions from basically a group of people. So could you just explain a little bit more about the audiences or the targeted people on this survey? So whom did you ask those questions? Whether the parents of children or children themselves, or could you just explain a little bit more, please?
Okay, so since we didn't get children to actually play the game, so we went to preschools, then we asked the teachers there, and some of the parents were asked.
So was it the parents or the teachers? Sorry, I didn't understand
It
properly.
was the parents, then also the preschool educators, then also people that
Okay.
usually are good at playing games and how games are.
Okay, so that means that children themselves played the game, but the questions were asked from their parents. Was this the methodology?
No, children did not play the game, yes,
Okay.
but yes.
Okay, so yeah, okay, sorry, I don't think if I understood it properly. So who played the game and who were asked those questions in the survey?
It's the perceptions of the teachers and
The-
the educators.
The opinions of the preschool educators and also the teachers, the guardians.
Oh, I
were-
see. Okay,
yes,
you just
yes,
demonstrate the game to them, and then okay, so okay, get it.
yes.
Okay, thanks very much. Thank you.
Any more questions from the session chair?
No more question from me.
Okay, we can move on to the next presentation. So now I'd like to call upon Mr. Rezvanul Parvez for his paper titled Understanding Bankruptcy Prediction Using Data Mining Algorithms, Evidence from Taiwan's Economy. So you may please start your presentation.
Thank you. Let me share my screen. Can you hear me okay?
Yes, sir, you're audible.
Thanks. Let me know if you can see my screen.
Yes, sir, it's visible.
Hi, welcome everyone. Thank you. Local time here is 8:30 in the morning, so good morning. I know people joined this meeting from all over the world. Good afternoon to the people who joined from UK. Good evening to those people who joined from Africa. Good night to those people who joined from India. So as you see from this title, we are dealing with bankruptcy. It's a big issue. We know, pretty much everyone knows basic economics, right? How the economy run, how the financial organization play a role in the economy, and how vital is the issue of bankruptcy when the corporate firms or financial organization or commercial banks went bankrupt. We see the impact in the economy immediately. Like in the short run, we don't have to wait for the long run to see the effect. The whole economy will collapse, the government will collapse, and people will, talk about this all the time. Hey, our banking system failed and our economy is failing. So I think, we thought that it is very important to find how the bank fails, why the bank fails, and how we can predict that if this metrics is not looking good, might 3 months down the road, bank might fail. So you have to take preventive measure to avoid that financial loss or the collapsing of the economies. So I think we are addressing a vital issue in this paper, and I would like to thank all of my co-authors who contributed equally. And we have people, our team is pretty diversified. We have authors from, like our first author, Saidul Arif, and he is from business background. I myself, as a data scientist, we have industrial production engineer, we have machine learning engineer, Dr. Hassan, we have faculty, teaching faculty, research faculty. Everyone comes into play to share our story. And we'd like to again thank ICICT, International Congress on Information and Communication Technology, to give us this platform to talk about this. So the outline, first I'll talk about the introduction. What does bankruptcy mean? What's the existing literature discussing about this? How we can predict this? What sort of modeling is good for this? Then we'll talk about our research question. What are some of the research questions that we try to answer in this paper? And then methodology, and then results. What are some of the findings that we have from this paper? And then at the end, what's the justification of this study and the future research direction? What more can be done on this issue? So first of all, introduction. Bankruptcy, we kind of know what does it mean, when firms or financial organization or commercial banks, they have obligation, right, to their creditors, to their customers, to their, whatever money they are using is people's money, is financial organizations, so they are obligated to their customers. And when they fail to entertain their obligation and pay back the money they receive from their creditors, that stage of that economy or the organization we call bankrupt or bankruptcy. And in this paper, we will see how the corporate bankrupts, and based on Taiwan, this is a real data set. This is what happened during that time at Taiwan's economy. And so we can learn from them. How can we avoid such kind of financial loss in future? So we know bankruptcy definitely will lead to financial distress. The banking system will lose money, the overall economy will lose money, and we know the effect, the long run and the short run effect on the economy as a whole. And as I said before, this data set is based on financial institution, almost close to 7,000 observation. Our sample size was close to 7,000. So we'll see that effect. Who is our stakeholders for this bankruptcy? The customers who will be affecting due to the bankruptcy: employers, workers, administrators, And and if a firm went bankrupt, what should we do? Probably a way is we should restructure the debt, and probably we'll liquidate some of the assets to cover some of that financial loss. Bankruptcy prediction model, according to established literature, existing literature, there are a lot of modeling, most of them conventional modeling, like statistical modeling, regression modeling, all sorts of Markov chain modeling, all sorts of statistical modeling. And some of the recent published literature, they adopted or employed some of the machine learning model as well to predict bankruptcy. But how is our paper different from that is we employ a different machine learning algorithm, but we also created a subset of variables. Like we have a long list of variables or factors that impact bankruptcy, but how we choose or develop the most significant one that are impacting bankruptcy. So, and this is the paper we dealt with the data of 11 years of data since 1999 until 2009 on Taiwan. A lot of firm went bankrupt during that time, and that time the island nation, whole banking industry, observed a tremendous pressure to evolve and adapt. And we know the geopolitical reality that existed in Taiwan. And so in this paper, our research question is, number one is, what are some of the primary features or determinants, or we call it variables, that caused bankruptcy in Taiwan at that time? And how can we identify them and examine them, like how significant they are in terms of predicting bankruptcy? Number two, what is the level of effectiveness? We apply different machine learning algorithms, 4, 5, 10 different algorithms to see how effective they are. Like, is the random forest is the best? Is gradient boosting is the best? Is the shallow machine learning is best? We'll see in our results section. And then how significant is each our element in forecasting bankruptcy? So the methodology is 11 years of data. We have the secondary database. This is a public domain knowledge. You can easily download that data set from University of California Irvine Machine Learning Repository. And we download that data set, and we have 96 variables, including like financial ratios, economic variables. And total, we have 7,000 observation data on 7,000 firms or financial organization or banks, and we use 70% of that data to train our model, and then we use the 30% of that data to test our model. And we play with a lot of different machine learning algorithms, but these four stood out the best: the logistic regression, the random forest, the gradient boosting, and the extreme gradient boosting in terms of accuracy, how accurate they are in predicting bankruptcy. And how can we tell that this model is best? The performance of machine learning model, we can tell using several performance evaluation metrics, we call. And they are known as accuracy, precision, recall, and AUC or ROC, area under the curve. And also at the end, we'll end up with the feature importance analysis. So this is our whole data life cycle. As you see, the data set is available. We save that data, pull that data, then the pre-processing of the data, if there is an outlier in the data, if there are missing values in the data, if the data is not normally distributed. So we did all those things under data pre-processing. And then, as I said before, we shortlisted our variable, like we have, as I said, 96 variables. So we'll create a subset of those. And then we'll train our model by using that subset and test our model. And then after the testing results, we'll see finally what variable is impacting the most. So raw data set, we created two different subsets of data from that original database. The first data set is generated by passing the raw through the outlier elimination. We remove the outliers, and then we normalize our data. And then the other data set, we take the log transformation of the data and normalize that data. So today we created two different data sets to train and test our model. And the variable selection method, how can we select the subset of variables? We use 4 distinct methods. The variance threshold method that told us that out of those 96, these 22 are critical in prediction of bankruptcy. And then another method, RFE, recursive feature selection method, that told us that out of these 96, these 15 variables are significant. And then a stepwise logistic model said these 18 variables is critically important. And then also you have to apply our domain knowledge. Like we know banking is not always financial ratios or cash flow, or there are a lot of other geopolitics that you need to consider when you are talking about Taiwan. There are like China is around there, India is around there. So you have to calculate that geopolitics into what's happening in a certain country. And then the other economic factors as well, like liquidity, profitability, the operating efficiency of that bank, of that firm as well. And this is our original data. As you see, the data is highly imbalanced as it is, like how many firm non-bankrupt, bankrupt out of the 7,000. Then we decided to use an algorithm called a SMART, a synthetic minority oversampling technique.
Sorry to interrupt, sir, but 10 minutes are over. You'll have to wrap up a bit.
Thank you. Sure. To address the data imbalance, and after we balance that data, as you see, as our binary dependent variable 0 and 1, that's the picture we look at after we using a SMART. And then the critical few findings that, as you see from the RSC curve analysis, true positive rate, as you see those 4 machine learning model, logistic, random forest, gradient boosting, and XGBoost, all AUC value are more significant, like higher than 0.5, implying the model performance are better. And then in dataset 2, you see that number went up, AUC value went up to 0.9. So that's a big change in terms of data, because after rebalancing that data, after using that SMART algorithm, we see the better performance of those models. And in terms of those evaluation metrics, as you said, the logistic regression, random forest, you see the gradient boosting number is really high. Their precision is almost close to 0.92. Recall is 0.86 in dataset 2 after you balance that data. And F1 score is almost close to 0.9. So that means that model performed really well compared to other data machine learning algorithm. And the feature importance analysis, that will tell you which variable are most significant. And as you see from that histogram of the bar chart, the net income to stockholders' equity is by far the significant variable impacting bankruptcy. Then the net value growth rate, the borrowing dependency, and the persistent EPS that refers to electronic payment standard in last 4 seasons. So those are the highly significant according to our feature analysis. And at the end, our first objective was which machine learning worked best in this data set. As we see the findings, XGBoost has 97% accuracy to predict bankruptcy, whereas random forest said 96% accurate. And which variable are significant? These are the variables that are positively significant with bankruptcy prediction. Quick ratio, current ratio, there are a lot of financial ratios you see. And which variables are negatively correlated? Long-term fund, total debt, total net ratio, and current ratio. And then we have some limitation as well. We use shallow machine learning model. We could have used some deep learning model like neural network, but our sample size was not big enough to apply those model. And our data set, as we said, only limited to Taiwan. If we could have add some other bankruptcy data from China or maybe India or some other South Asian country, that would give us a bigger picture or comprehensive picture that this impacting the South Asian economy as a whole. And we only included financial ratios in this model. If we have some data on how to include like the geopolitical issue that's happening on those regions, on those island nations, that could have been give us a way better picture as well. And at the end, we know this results is easily adopted. This modeling technology can be easily adopted. And future research, as I said, if we include some of those other socioeconomic, financial, or geopolitical variable into our model, we could have seen a better picture as well. So thank you, everyone. And anyone have any questions? Thank you.
Thank you for
Any
the wonderful
questions?
presentation. I have no questions. Thank you.
Any more questions for the presenter? No questions, I guess. So we can move further. I sincerely thank our authors. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for the support during the 9th version and all the previous 8 versions of this conference. We will be happy to have you in the 10th version in 2025. All the presenters would be given digital certificates via mail within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2024. I would like to thank our session chair, Professor Farshad Tusi and Professor Swati Nikham for chairing this session. This is a token of appreciation to the chair on behalf of Team ICICT 2024 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence. So before ending the session, I kindly request you all to switch on the camera for a quick snapshot of this virtual conference. Thank you so much for being a part of this session. Have a good day.
Thank you, everyone.
Thank you.
Thank you. Goodbye.
Thank you. Goodbye.